Now we're going to talk about nuclear power. Nuclear power is the primary non-fossil fuel renewable resource in the world. It's probably the only one, actually.
It's a pretty good statement. Primary non-fossil fuel non-renewable resource.
20% of your power, of the power in the United States, is produced from nuclear power. And nuclear power comes from the uranium ore. And what happens is the uranium, through a process called fission, or blasting neutrons to split the atom, release heat on a molecular level. But this process is done billions of times to produce heat, used then to heat up water. And I'll show you what the power plant looks like. You have to know that uranium-235 is used. It is that isotope of uranium. And I say that it has a low net energy efficiency because even though you may have heard that uranium produces a lot of power from one pellet, the whole process in of itself uses too much energy expenditures. For example, the process of refining the uranium, then the life of burning it, and then the post usage of uranium when it is stored in a building for containment, and then later when the plant is decommissioned. Next slide. There are two types of uranium power plants. The first one is a boiling water reactor, and what happens is the water is pumped through the reactor core. The outside is the containment shell, and the water is heated through the heat released from fission, and that water flows through the pipes, turning a turbine, which produces electricity. The next type of power plant, nuclear power plant, is called pressurized reactor. And what happens is water is put inside of a pressure vessel inside of the reactor, and the pressure water is inside of a pressurized vessel, and heat is placed around it, and then it's heated, and that pressure turns the water into steam to turn a turbine. The pros of nuclear power is that no CO2 is released in the process of creating the electricity. However, a con could be that throughout the process of transporting the uranium, mining the uranium, CO2 is released through the burning of fossil fuels. Another benefit is that the governments, because it is so expensive, governments give large subsidies for nuclear power plants to be built, so it's relatively affordable because of the subsidies. Cons are the financial cost, the cost to build a reactor, the cost to make sure that the reactor is safe, and then when the reactor breaks down, the cost to decommission it. And usually this price ranges in the billions. Maybe a nuclear reactor in its lifespan could cost around $500 billion. Another con is that in the process of fission, uranium is radioactive, and radiation kills people, literally. And the final problem is that nuclear power can be used also in the making of weapons. So as a result, power plants have to be more secure.
I just want to clarify here. Can you guys explain fission?
Yes.
Okay.
Fission is one uranium-235 atom. A neutron is released, and that splits the atom in half, releasing more neutrons, and in the splitting, heat is produced. Now the neutrons that were released hit other uranium, releasing more neutrons, and the process continues exponentially. Think of it as mousetraps in a room and throwing one ball. The first mousetrap is released, releasing the ball again, And before you know it, all the mouse traps are set off. Now, to control the reactor, control rods are brought down to regulate the heat so it doesn't overheat, which could be that too many of the mouse traps are being released at one time. Too much heat could melt the reactor. So control rods are set down maybe to stop the mouse traps.
They're set down to absorb neutrons, okay? And all this takes place, just to clarify you guys for the exam, it takes place inside a containment structure, which is made of steel and concrete, extreme thickness, and well, all that takes place in the reactor core, and the reactor core is surrounded by the containment structure, okay? In order to protect it. Good. Renewable energy.
Okay, renewable energy.
Oops.
Okay, renewable energy is a source of energy that is not depleted by use, such as water, wind, or solar power. Each of the renewable energy alternatives have advantages and disadvantages. Renewable energy is not being used as much as it should because there is no financial incentive to move from non-renewable to renewable. The prices we pay for current energy, non-renewable, do not include their harm to the environment and to human health.
That's an AP question. None of the costs include environment. Remember the whole disadvantage column for every single one? No cost includes environmental damage
was
or.
like the first thing.
Yes, it is? Oh,
Yeah,
it is. Whoops. Oh, boy, my hands don't work. Okay. Go to the next one, but I love this side, so pretty. Okay.
First, we're going to talk about solar, and there are three popular types of solar active systems. There's parabolic trough systems with U-shaped domes that focus sunlight into the central tube in the middle, and the tube has oil, which is then heated by the sun, and then it flows to a generator, which then starts the generator and the electrical energy. The dish/engine is a metal dish that concentrates heat onto a receiver, again in the middle, and then the heat expands the fluid and turns a turbine, which is mechanical energy. And then the mechanical energy is sent to the generator, which then is turned into electricity. The third one is power tower. It's a large field of mirrors, concentrates the sun to the tower top receiver, and the top has salt, and the salt is heated, and the hot salt generates a steam generator, and then electricity can be stored for a rainy day using this system. There are two types of solar energy. There's passive and active. Passive is a direct flow of energy. There is no system. It just collects the heat, and it's the most efficient form of heating. Active has a system. It usually uses panels or mirrors, and some examples are solar thermal heating systems and photovoltaic or PV cells. And solar is also the fastest growing renewable energy resource. A pro is it's sustainable. We have the sun. It's low cost. It's low cost after the initial cost of installing and buying the cells. It's abundant, it's non-polluting, and it's multi-use. It can technically sub for petroleum, but it's not very efficient in that method. Okay. Cons, there's uneven availability. Obviously, countries closer to the equator where the sun has stronger rays are going to get more rays than like Alaska. There's no energy at night, but this is kind of an iffy con because if you have solar energy, you're going to obviously have the correct equipment to store it for nightly use. Large power plants take up large amounts of land. There's high initial costs, as I said earlier, and it's expensive per kilowatt hour when you buy from power plants.
What are solar panels made out of?
They're photovoltaic cells.
What are they made out of?
So,
Silicon. Okay, you have to know that. That's definitely a question.
okay, geothermal. Geothermal energy comes from underneath the top part of the ground. It's 10 feet underground, has almost a consistent temperature of 50 to 60 degrees Fahrenheit. In the U.S., geothermal energy is mostly found in the West, in Alaska, and Hawaii. Some plants use steam to turn turbines directly from geysers. These are called flash steam plants. Others use hot water to produce steam and turn a turbine, which are called binary cycle plants. And the geysers in California and Yellowstone in Wyoming are popular places to collect the geothermal energy.
Can you tell me types of geothermal energy besides geysers?
There's not volcanoes, but underneath the volcanoes, like where
The dry rock.
Dry rock. What else?
there's wet rock and then the steam.
Okay, good.
This is a geothermal energy plant. You can see the rod is in the earth collecting the heat, and then it brings up the steam, which then turns the turbine and is generated electricity. Geothermal heat pumps, these are used to heat circulating systems. There's 3 different parts: the ground heat exchanger, the heat pump, and the air delivery system, which is also called ductwork. The ground heat exchanger is a system of underground pipes.
We don't have to know that. Now that's an AP question. Just do it.
I'll do it.
Okay.
It's a system of underground pipes near a building with water and antifreeze circulating through it. The air delivery system circulates hot or cold air throughout the building. And the heat pump in winter moves heat from the exchanger to the ductwork, but in the summer it moves heat from the ductwork to the exchanger.
So more important, you have to know that geothermal energy can be used for heating and and electricity production. Those are the 2 things, okay? Because you gotta think of heating. Solar does it too. Natural gas does it. You can't use coal for heating. You can't use nuclear for heating, but you could use natural gas. So some people need heating systems, and this is an alternative to that. Okay.
Pros and cons of geothermal energy: it's sustainable. Some say it's technically non-polluting. It does, as I have listed under the cons, emit CO2 and hydrogen sulfide, but it has less emissions than other sources of energy, so it's considered non-polluting, even though it does pollute somewhat, but it's less. There's continuous production. It's inexpensive after startup costs, and you use a relatively small amount of land. The con is potential groundwater contamination with chemicals from the factories going down, because you're already down in the earth trying to get the heat. And there's bad reservoir placement. A lot of times the reservoirs of the heat are hard to get to, and you can easily damage the ecosystem while running. Hydrogen energy. We haven't talked about this before, but hydrogen is the most plentiful element on the earth, though it is never found alone. It's always locked into a compound. It can be easily stored and transported, and it's often found in hydrocarbons and fuel. Fuel cells are hydrogen and oxygen. They give you electricity, and you can heat your water. Hydrogen fuel cells are used by NASA, and the fuel cells are like everlasting batteries, but the catch is you need to have a constant supply of hydrogen to keep the fuel cells going, otherwise they will run out. There is no pollution from using hydrogen fuel, and the engines that you can use for hydrogen, they work best with hydrogen, but you can also use natural gas as a substitute. In the top is a diagram of hydrogen being harvested. You see the sunlight in the water, in the tube, and then the water evaporates, the oxygen evaporates, leaving just the hydrogen, which goes into storage, and then it's used in the hydrogen engine.